Hello everyone. My name's Simon Brennan. I'm from Astute Electronics, and we're going to be running through a series of presentations from a group of our franchise suppliers today. We've got 5 in. I will start and end the presentation. Please feel free to ask questions. We'll also have a spot at the end if you do have any questions for me. But first and foremost, I'll talk about Astute Electronics. So those of you who don't know who we are, we're a privately owned electronics distributor, UK based, so the head office is in Stevenage, but we're now up to 22 global offices. Actually, I found out today the number is a little over 200 million turnover last year and 420 employees worldwide. So we're growing quicker than our presentations can keep up with at the moment. Really, we come from the high reliability sector. So, bear with me. I think I might need to be closer to this for the clicker to work. Yeah, so head office there in Stevenage, UK, just north of London. We've got every one of those countries in orange. We have a physical presence, so staff in country, generally covering a wider territory than that particular one there, but say the Nordics are covered from Finland and Sweden, and they cover both Denmark and Norway as well, as an example. In terms of operational capabilities, we have distribution facility and an anti-counterfeit test lab, both in the UK, in Munich, in Austin, Texas, and in Hong Kong. And we also have a distribution facility in Melbourne. I'll talk about what we actually do in terms of counterfeit testing, counterfeit mitigation that I've referenced there. I'll talk about that a little bit later on in the presentation. But you can see the setup of the business. You know, we are one Astute Group. There's been some acquisition over time to grow our footprint, especially in Europe. But yeah, a growing organisation, and there'll be more countries on that list pretty much month by month at this rate. So we really come from the defence and aerospace sector. That's where we've cut our teeth over the last 35 years. So high reliability. And we're multiple things to those customers. We've grown with them based on what they need from us. But we're branching out more and more into, say, industrial automation, IoT, medical. Really, we're adding lines that support those technologies, those vertical markets. But we're also finding that certainly customers like medical have very similar needs to the high rel sector, so defence and aerospace. So all the services we've built up over this period of time, the lines we have on board, all lend themselves very nicely to some of the customers we're bringing on, but we're also bringing on some new lines as well with different skill sets and different products. So services-wise, we're really built of 3 key sectors, but the franchise electronics, I'll talk about here, it's probably a bit of an easier slide to use. So the franchise electronics is a demand creation team. So we've got now 20 technical business development managers, a combination of electronics engineers and just industry professionals like myself. I'm not a trained engineer, but I've learned the trade working for manufacturers, learned my technologies. I'm from a memory background, but we cover passive and discrete componentry, active semiconductors, power, interconnect, ruggedized displays, high fidelity audio. The list goes on. And we've effectively added these technologies for lines that are well suited to our customer base and want that resource in demand creation specialists. So our role is effectively to be out on the road in front of engineers saying, what problems have you got? What are you trying to achieve? How, are you aware of this manufacturer? Did you know this technology existed? So it's really introducing the manufacturers to the customers and acting as an interface, because the engineers these days do not have time to be trawling through Mauser and DigiKey, who do a very good job. I'm not putting them down, but it's a closer relationship with the market and with our specific technology verticals. In the global sourcing or fulfillment sector here, this is really where Astute started and what we're very, very accomplished at doing. We've been doing it for, as I say, 35 years now. Effectively, we're getting a bill of materials from a customer. So they've done their design work, and then they need to go out and source it. And we can take that bill of materials, we can do a cost down exercise. So, scouring the market globally to find, we've effectively got 3 routes of supply. So route A, direct from manufacturer. Route B is from manufacturer's distribution. And then route C is non-franchise distribution, so non-traceable product. Route C I'll talk about in a moment, but effectively through those different routes of sourcing, we can go across the market globally with that presence that I pointed out on the map, to offer cost downs for customers, to offer supply chain services, and that really lends its way forward to support. So that can be things like taking over a bill of material. So a customer's done their design, they don't want to get involved with the build, so we can take that bill of materials, we can source it, we can warehouse it, we can then kit those together, ship the kit to the CEM, and actually take the built kit back from the CEM and ship that out to the customer's end, or our customer's customer. So we can cut down their time from expenditure on componentry to when they're actually getting paid by their end customers. So it's really grown through what our customers have asked us to do over the past 30 plus years. So the franchise at the electronics team, I went into a bit of depth there, but we're now something like 135 lines, 140 lines, one of which we signed yesterday, formally. We've been discussing it for a while. John will be up talking in a moment. But as I say, technical FAEs, so somewhere between business development managers and FAEs is how you'd look at us. So Dave, who's speaking a bit later, is a trained electronics engineer, a lot more knowledgeable than me about the market. But yeah, we're doing things like engineering value clinics. We'll go into a customer, we'll lay out all of our technologies in their canteen, and they might have a couple of hundred engineers working there throughout the day who will come down, pick up the components, talk to us, just get to know us. And effectively, we're a free resource. Give us a call, tell us what you're struggling with, and we will hopefully be able to recommend some componentry or solutions that will help solve that. So without any further ado, I'm going to hand over to John. Thank you, sir.
Cheers, mate.
Yes, please do.
Right. Well, ladies and gentlemen, hello. I'm delighted to stand here on behalf of Astute, my newest partner. So we became a franchise partner of Astute last night. That's when the contract was signed. But we've been talking for many months. Me personally, my name's John Wilkins. I've worked for Axelera AI for 8 months. I'm the global channel director. We're effectively a startup. We're in our 4th year. And our product, it went general availability for hardware and software last month. So it's a very fresh product. The team that I joined, they've been developing custom hardware, a RISC-V based chip. So we design the chip, we own it. RISC-V is a great architecture. You can interpret video very efficiently at low power. And when you talk AI, interpreting video at low power is exactly what you need to do. On top of the RISC-V chip, we've got memory, so the algorithm sits there on top of the cores at the edge. So that's what we do, and it's very new. I joined as channel director, and I soon found out there was no channel to manage. I had to go create it, and that was wonderful, because after 23 years at Intel, it's been great fun going out there, explaining our technology, and finding the right companies on the planet that can move it forward. So I've got 5 distribution contracts out there at the moment, and the first one closed last night. I am delighted. So thank you, Astute. So look, I standing up here for 15 minutes, I want to let you know who I am, what we do, and how to apply it. That's the aim of this session. So when we talk about AI, where we add value and where we have current customer developments and deployments, it's mostly in these segment areas. And you'll hear AI mentioned an awful lot. But you don't do AI for the sake of doing AI. There has to be a purpose. There has to be a value. You have to create or generate some form of insight. And the types of AI that our partners are doing are here. So, you know, we're either monitoring traffic, monitoring objects, monitoring people, behavior, flow. These are the activities that require a video camera, it requires processing of a live video feed, and it requires algorithms. And sometimes more than one algorithm is running at the same time. Now, to date, AI, people have been throwing GPUs at AI. GPUs were designed to render graphics. Very, very capable equipment. But they weren't really designed to run at the edge. They tend to be power hungry. They tend to be costly. And effectively, that technology was repurposed to AI at the edge because it worked. But it doesn't work efficiently. So the founders of my company set out to look at what potential technologies existed today that could do it more efficiently. And effectively, that's what we've come up with. So our Metis chip, it has 4 RISC-V cores. And it has a dynamic in-memory controller that sits on the cores. And we attach to a host CPU in a system, and we basically make that system able to connect more video cameras and manage more algorithms for the cost of a couple of $100. So we're extending the use of a system using our AI technology at a very cost-effective way. So when you rush to Astute to get your quotes and understand what kind of products you can apply, this is what the products look like. You can have modules, single board computer, and these are all in mass production and available now with more products on the way. Now, I didn't really want to talk about products because it can be quite boring. What I'd like to talk about is actually what we do. All right, so this is an actual customer deployment. It's a working kitchen in Southeast Asia. And what the government wanted to do was, first of all, monitor employees to make sure they're safe. So an algorithm is checking whether protective equipment is running. Is on the employees. The second thing the government wanted to do is check work productivity. So there's a pose estimation algorithm, making sure that those workers are happy and effectively going about their job. The third thing the government wanted to do is ensure that the workers were not stealing food. So, it starts off as quite helpful to the employee, and there is a slight twist at the end. But this is government food. It's a school kitchen, and they're worried about loss. So there's 3 different activities going on here. What they like about our solution is they're able to run an algorithm on 2 cores and another algorithm on the other 2 cores. They're running at different frames per second. So it's live video, and we're able to cascade. We're able to do real-time analysis in a low-power system. They tried to do this on a low-power Halo solution, and they were unable to do this amount of algorithms at the same time. Yes, they could have done it with an NVIDIA GPU. They tried to do it with Jetson Orin. They couldn't do it. So they were very happy that ours had the capability and the efficiency to do this at the cost point required. The second example, and it's not running. There we go. So the second example is in a retail store. Okay, so if you've been to a cash point in a retail store, there's actually lots of cameras, and it's monitoring the shopper. It's monitoring the objects that you're scanning, and it's making sure that you're scanning and putting it on the weighing scale rather than straight in the bag. It's actually very complex to do this. There's multiple algorithms happening at the same time. This is in a retail store where there's a desire to have a high volume of these devices. And once again, the way this has been being done is to have effectively a small data center in each supermarket, stuffed full of NVIDIA GPUs. It's not cost effective. So our solution does this at low power, low cost, in an efficient way. The other example is in a museum. So in a museum, you want to monitor the people. You want to track how they're flowing through the museum. You also want to segment the room to work out what is a ornament or an area of interest. So you've got one camera here, not only doing people flow, finding and tracking the people, but also analyzing how long people are interacting with each ornament with each exhibition piece. So there's a lot of insight here. And then, we've also got customers that are super impressed with what we call tiling, the ability to see a large video screen, but actually work out a small square where you can zoom in and have a much higher quality of picture. Again, we're doing this on a low-power industrial device, okay? So what we say is you kind of get enterprise-class performance, but at an industrial low power and an industrial resilience. So Astute, having the military, avionics, defense, industrial customer base, we're delighted to be able to take this to market and introduce it to their customers because, this technology has not existed before. So that was all I had to say. We're a new partner to Astute. We're open for business. And where you see AI and where you see video, you should see Axelera AI and Astute. So thank you very much.
Thank you very much, sir. Very kind. So from one of our newest partner, we now move to one of our longest standing partners, Innodisk, and we've got Chad Wu, who's going to come up and talk about there we are, Apex product range.
Yeah. Thank you. So, hello everyone. I'm the Innodisk. My name is Chad Wu. I'm going to do some presentation to introduce what we do and what we are going to do in the future. Speaking of the Innodisk, many of you may think why we are here and why we provide AI. What the relationship between AI and Innodisk? In the past 20 years, Innodisk provide the module for the memory and flash. And nowadays, we change some of our business into the AI systems. And now we start to build our systems to our customers who want to focus with AI. And now we more focus on AI at the edge. And why AI at the edge? What's the difference between the AI at the edge and maybe in the cloud? And why we want to focus on the edge? And to start these sessions, I want to you can try to imagine that if you use AI all the times, you send all the data to cloud. Would you worry about that? Would you may have some concern about your data, confidentials, something like that, and maybe some efficiency like that? If you do that at the edge, you don't need to worry about this. And there are many beneficials. Like efficiency, you don't need to wait to transfer data to the cloud. You can cost saving. You don't need to pay for the data transfer fees, and also low latency. So many beneficials you can do at the edge. Now in Disk, we have some cases with our customers like traffic, automations, industrial, retail, railway, and some of our customers are doing the parking systems. Okay, so we now also provide not just the modules here. So here's the whole picture is what we provide. And these 4 systems are ready for our customer to use. And for example, at the bottom line is the entry level with the Intel CPU only without the GPU supported. So it's a very low power consumptions. And the toughest is with the 6000 ADA GPU cards supported. So you can, based on your use case, to choose which model you like and which model you need. And not only the systems, we also can provide the cameras. And we can also provide MIPI cameras, GMSL, and also the USB camera as well. So everything's. And with not only GPU, also we can combine with AI accelerators like John, Axelera, very powerful AI accelerators. So it's one of the options, very good options, low power consumptions. So we try to provide the whole sets, whole solutions to our customers for the many verticals here. Okay, so here are some of our the pictures. I won't speak too much at these pages too much, but just let you know that for our products at this and different different level of the performance. And now also we are doing the topics that's for the AI server, and this is based on the NVIDIA MGX structure to do the AI server, and can support up to 2 H200 GPU cards. And that is we will release this product in the end of this year. And also we want to share what the difference between these models. We have the most powerful, this one, around 18,000 CUDA cores, and with this one, 9,700. So it's like lot of powerful here. And comparing to the target application on the top, so if you are looking for the system use cases for like LLM, you want to train like a ChatGPT inside your company in the edge, so you can looking for like our system here. And if you are just looking for low power side, so like facial recognitions or the license plate recognitions, you can just looking for just entry level systems. So all of our products can map into some your target applications here. And of course, when you are looking for the more powerful systems, the cost will be higher. So that's why Axelera is a very good choice with our systems. And at the edge, Axelera can also come with low cost systems, and we can provide together to the edge. And if you want NVIDIA, yes, we do have also can provide NVIDIA solutions. And also with the same pages, but we change to tops. Before it's the CUDA cores. If you are more familiar with NVIDIA terms, you may think about CUDA cores. But if you are thinking about AI performance, you may more familiar with tops. So at this page, we try to calculate how many tops at our system we can provide. And the top is will be like 1,400 tops. So it's very, very powerful systems. Oops. Okay, so this is comparing to the cost as well. And also, just again, want to mention about if you are looking for the Intel with the NVIDIA GPU, the cost, the price will be higher. But also, we also can provide them with the LLM and some like AI model training systems. And if you're looking for the some entry-level Intel CPU only, we can also provide. And now we are now also working with Qualcomm. The Qualcomm platform systems, they are now also planning to have a new system and now more focus on the AI purposes systems this year. And we may work with Qualcomm, have some new products in the end of this year. Okay, oops. Okay, and now I'm going to do some case sharing to you, and what do we do recent years, and what do we provide to our customer, what they do. This one is our products Apex E100, and this is with the Intel Meteor Lake PS, and this platform only designed by Innodisk in the market, and can provide like 36 tops from the systems, and some of our customers they're using for the transportations to check the traffic flows, and also in some smart cities. Okay, this one is in the United States, They are now using our systems with the MIPI camera. Why they choose MIPI camera? Normally, we may find a customer will choose like USB cameras or Ethernet cameras. With MIPI camera, this can provide lower latency for customers. And sometimes, if they hope to take the pictures without any latency, they will choose the MIPI camera. And also, Innodisk can provide the whole sets, including MIPI camera and the whole systems. And actually, this system already certified by Intel. So Intel also recommend to talk to their other customers, and they can to think about these systems to use in their AI purposes. Okay, and this is the diagram in the United States. What do? They like the MIPI camera. They keep monitoring in the field, and then find something wrong and go to talk to the operators and give an alarm, and then someone will come to solve the issues. Okay, and here are just for your reference our products here. Okay, just for your reference here, how we have this board to connect to the MIPI cameras, so it's easy to do. Or in the future, if you need like a GMSL, we can change the board to GMSL cameras as well. So it depends on your requirements. Okay, this one is another system, P200, come with 2008 GPU cards. Okay. This is a case in Japan. It's a very unique use case for parking space. You cannot imagine why they need GPU cards for car license plate recognitions. Normally in Europe, your car license plates only come with letters, numbers. In Japan, their car license plates come with Chinese wordings, Japanese wordings, English, and numbers. So without GPU supported, the car will queue in there, stop at the gate, and for 30 minutes. It's not a joke. And no one wants to wait there for 30 minutes, So then after they try a lot of systems, they decide to use our systems. Why? The gate can open in 3 seconds. So it's efficient for them. And this system is the world's smallest system to support MXM GPU cards. So they can easily to put the system in the gate. And also support 2 PoE cameras. So one in the front and one behind the cars. So very easy to them to install the camera with systems. So now we ship to Japan every month, couple of systems to them to replace their previous systems. And before that, they doing something not good way. They put a very big systems in the center, and they use a very long cable from center to connect to a camera at the gate. Now they don't need it anymore, so it makes them easier to set up the parking systems. Okay. Yeah. So this is the case at here, just like I said in Japan. Okay. And this is a unique design for these systems, and we have 2 very strong fans for our CPU and for the GPUs together. Okay, so based on this system, we also provide a Halo, if you want to do with Axelera as well. so you can do like, or you can choose the NVIDIA GPU. Okay, so I think that's it for my speech. So if you have anything you want to ask me, you can come to our booth at J4. Thank you.
Excellent. Thank you, Chad. That was brilliant. Thank you very much, Chad. And then next up, we have Alex Munden of Fortec. There you are, sir.
Okay. Hi everyone. So we've had a couple of interesting talks about AI. I'm going to simplify things a little bit. I'm here to talk to you about displays, specifically our VacuBond technology and how that enhances these high performance displays. But first, a little bit about us and me. So we are Fortec UK, part of the Fortec Group. We're a hardware solutions provider specialising in display assemblies, where we're taking LCD displays, glass and touchscreens and bonding them together, embedded computing and power electronics. So for me, I've been with the company nearly 10 years now. Started off 2 years in our technical team, then spent 2 years in our technical support team, and then moved on to spend 5 years in our sales engineering team. During that sales engineering time, that's where I got given the nickname Babyface Guru by our internal team. Partly because at the time, and I say at the time, I'll leave it up to you guys, I had a baby face, so be kind. And also had a bit of a technical background, so Babyface Guru was the name I was given. And then in the last 6 months, I've taken on more of a sort of a business development role, which is in having some new challenges, but I like to come across to these events and do a bit more of a technical talk and put that babyface hat back on. So now I'm nearly a decade old piece of furniture. That might be my new name. So displays in smart cities. I suppose when we talk about smart cities, we're getting into the realms of systems becoming smarter, and everyone talks a lot about AI and introducing that into systems to make the systems themselves a little bit more self-sufficient and making, well, in essence, the city smarter. When we talk about displays, we're talking more about providing information to the user. So the systems that need to provide some sort of data set or maybe some timetable information at a bus stop to a user. These displays are making the user smarter to make smarter decisions. Things like smart bus stops, EV charging stations, or wayfinding kiosks, not limited to that, but any sort of display that might be in a city of any kind. When you're integrating these displays into those kinds of environments, there's some challenges to take into account, and this is kind of where we come in. So things like readability in bright sunlight, so being able to actually see that display and read the content. If the user can't see that content, how are they smarter? How can they make a smart decision? Durability, things like weather resistance from environmental impacts, and then shock and vibration things as well from things like vandal resistance. If that system falls over for one of these other reasons, again, users not getting the kind of smart data they need to make those smart decisions. So we come in to make sure that these display assemblies are high rel for a high rel environment to make sure that the user can make a smart decision. But how do we do that? So we have an optical bonding process called VacuBond. Now, there are a lot of manufacturers out there that offer optical bonding. This is taking a display and bonding it to a strengthened cover glass in front of it, maybe with a touchscreen in the middle. There aren't many companies that offer optical bonding outside of the Far East. We're one of the few. We offer that in Germany, in the Czech Republic, and also at a mirrored site we have just outside of New York as well. So we're able to offer this as a European manufactured solution. Now, as I said, we're not the only ones that offer this in Europe. There aren't many, there are a few. But we're one of the only ones that have our own unique bonding process, which is what we call VacuBond. The difference that sets it apart is all the other processes in the industry tend to be a wet or a dry bond process. The wet ones, as they sound, it's a wet silicon that gets poured into the display. That comes with its own challenges. And the other dry bond processes, similar to ours, they're almost like a 1 to 2 mil thick optically clear adhesive. Ours is a lot thicker. It starts at about 0.9 mil, works its way up to about 1.8 mil, so it's a lot thicker. Those dry bond and wet bond processes also use curing, so things like either a thermal curing or a UV curing process. Ours doesn't have a curing at all, so it simplifies our production process. It also, the way we essentially do it, and the reason we call it VacuBond, is it gets put into a vacuum chamber, we pull all the air out, and that's what brings all the substrates together. It also means it's reworkable. The other processes in the market, although manufacturers will say they're reworkable, they are, but you tend to get a bit of a yield issue when it comes to the rework. Our process is very easy. We almost get 100% yield out of reworking materials. So if something has to come out of the field, maybe the display's failed or the glass has been smashed, we can take back all the layers that are still working and bring them back into the production line and replenish them essentially. So this gives you a bit of an overview of some of the advantages. So there are two ways of bonding displays to glass in the market. One is a tape bond process, and the other is the optical bonding process that I mentioned. Now, tape bonding is basically taking an LCD display and a cover glass and quite literally add in a very high bond tape to the edge of the display and pushing the glass onto it. What you get left with is an air gap in the middle. Our optical bonding process replaces that air gap and that tape with that optically clear adhesive in between the substrate, essentially filling that air gap, so we no longer have an air gap. There are a few reasons that you'd want to do this, and if I come back to the challenges that I mentioned, sunlight readability. If you've got an air gap in between the display and the cover glass, when the sun comes down through these substrates, it then reflects not only off the display, but also the glass, and then those reflections bounce off one another. And then you start to impede the brightness output of the display. What that looks like in practice is the user starts to try and look at the display and he can't see because there's all these internal reflections in the layer. They can't see the content. Maybe there's some glare on the surface of the glass as well that's impeding that. Great, you've added a 2000 brightness display, and for context, brightness of the display 2000 candela. Your standard laptop screens are probably about 300, give or take. If we put a 2000 candela screen into an outdoor environment, it sounds great on paper, but if you air bond a bit of glass onto the top, you've paid all that money for that high-end display, and now you've ruined it with a low-cost assembly solution. So that comes down to the readability side of things. If we then start to talk about the durability, I mean, we're taking an air gap and filling it with a silicone adhesive. If somebody was to punch that bit of glass, that glass has room to flex and potentially break. Because we're filling it with an adhesive, if somebody was to punch it, that adhesive will take some of the impact. And so the glass is less likely to break. Not only that, but from an environmental point of view, when we're talking about weather conditions, an air gap, if you have the front glass facing to the external world, and that, let's say it's the winter, and we're talking about minus 10 degrees maybe, but you've still got some hot running electronics behind the glass. So now you've got a cold temperature on the outside, a warm temperature on the inside. What's going to happen? Condensation. And what don't you want in a room, in a little compartment full of electronics? Water. So again, you're taking a load of high-end components and putting them in an environment where they might end up failing anyway for no fault of other than the assembly method you picked. But if you go with the vacuum bond solution, you remove that completely because again, you're filling it. The gap where that might occur gets rid of it completely. And then it comes down to the vandal resistance. Again, that comes back to impact resistance. So fill it with the gel, impact, it's not going to break as easy. And what I've just learnt today, one of the other considerations with sunlight and displays is ultraviolet light. So ultraviolet light is damaging to displays. Our bonding process now blocks UV light. So where if you were trying to block it before, you'd have to add another UV filter onto the glass layer. With our bonding process, and this is unique to us, you don't have to do that anymore. Our standard bonding procedure blocks UV in any application. Doesn't matter if it's outdoors, indoors. Okay. This just kind of summarizes a bit of what I've just talked about. I mean, this just emphasizes only the advantages of vacuum bond, but we work on the whole assembly with Astute. So not just the bonding, but what display we pick, what cover glass we pick, and all of these come back to these challenges as well. Readability in bright sunlight. If we pick the right display, we have a high brightness display with a vacuum bond to reduce the amount of reflections. That improves readability on two factors. Durability, we can select a glass rather than a standard like soda line float glass that will break almost instantly to any kind of impact. We can thermally temper it or chemically strengthen it to make it a lot more susceptible to impact resistance. A good example is my colleague Brennan has a project where we've provided exactly this kind of assembly and our customers achieved IK10 rating. Now, for anyone that doesn't know, IK10 is an impact resistance metric, and IK10 is almost as high as you can get. It's essentially dropping, is it a 10 kilo ball, steel ball, 10 kilo ball from a height of 60 centimeters above it. If you do that to a standard solar line float glass, it will smash immediately, but our assembly doesn't. And they did this test again and again and again and again, didn't break. Weather resistance. Again, I've got add-in UV and IR protection filters into the glass there, but as I say, our bonding now has the UV filters built in. IR protection is the other end of the light spectrum from ultraviolet. This is more of a temperature-related thing, but we can add an IR blocking filter which further enhances the temperature resistance of the product. So that's my talk. If you want to connect on LinkedIn, there's that, or go see Astute on stand C1. Thank you very much.
Lovely. Thank you very much. Thank you, Alex. And now we're over to one of our very own, Dave Everett from Astute, talking about XMOS.
All right, good afternoon. All right, so I'm Dave Everett. I look after the XMOS franchise. So I'm going to explain XMOS. First of all, I'm going to start with a video. So the topic of this speech was about smart cities, and that's giving you some examples of the sort of things you can do with machine learning with XMOS. What I was going to take, because knowing this is a hardware show, hold on a second, there's bits of the slide missing. Okay, so this is a field programmable processor architecture. The outside of the part is very programmable. You may be familiar with VHDL to program your I/O on in a FPGA. The X-Core AI has that programmability on the outside, but it uses C programming. So you download C code. So if you want I2S, I2C, the interfaces that you need, you can define those on the outside of the part. It also has 800 megahertz CPU inside to do machine learning, DSP, and acts like an MCU as well. So it's a great performance part and very configurable. The type of examples I wanted to go through is this voice command with a. You may have an Alexa at home that you talk to. You say, "Hi Alexa," that's a wake word. The voice command implementation doesn't need network connectivity with the XMOS part. So you can chat away to it, wake it up, get it to turn things on. So it's getting strong interest in applications like microwave ovens and dishwashers, and one of the other areas is intelligent lighting, to understand what the room is doing and what the people are doing in the room by learning the machine, but without having to talk to the internet. So there's no additional data going up into the cloud, so privacy concerns are accommodated. So yeah, consumer appliances. Voice processing, one of the other areas, particularly in the health, digital health region, is using speakerphones or, again, intelligent lighting to monitor a room and learn the lady or the man who's living in a protected housing for old people, etc., to learn their voice, learn their activities, learn when they open cupboards, learn when they turn the taps on, learn they're moving around the house. Suddenly if they hear glass breaking, is it a window that's broken or is it a glass that's been dropped? Has the person fallen on the floor? And identify the voice of interest, a beam form to direct where they are, and provide digital assistance if required. Also used in conferencing phones. It was particularly popular in the days of COVID when we had home working a lot and smart appliances. Spatial audio, this one I particularly like. If you've got Dolby Atmos in your home, it has speakers in the ceiling, it has speakers around the room, and your ears, you've only got 2 holes in your head to listen to sound, one either side. So all the sound in this room is going in through 2 ears. If I can put headphones on you and send the phase of the audio in the right way to those that headphones, I can recreate a room. So you can have spatial audio. Typically, a Dolby Atmos is about 1 foot either side of your head. This is about 1.2 meters either side. So one of the things we did recently at a trade show was demonstrate it on a computer game, and the helicopter was definitely 60 feet or higher above you. You could hear it was absolutely above there, even though you were on headphones. Additionally, because headphones, the sound is bouncing off the walls, so your brain is actually processing the way the sound is in a room. And if you put headphones on, you have to increase the volume to get the same kind of effect. So by doing spatial audio, by doing it with DSP processing in an XMOS, we're reducing the ear pressure by 50%. So if you've got children playing computer games, you can now put the headphones on and they go a much lower sound level. This is all using a microprocessor with configurable I/O, and you're changing what it's doing. So it's the same part being used in each case. This is in a gaming headset. Denoising is another way of using AI to learn the noise in a room or the noise on a street. Imagine a doorbell listening to the street, understands what the traffic is like, understands lorries, understands trucks, and then can take that noise out and focus on the voice and let the voice through. So with again, not needing to connect to the internet, you can actually have a doorbell or an access system that can pick out the speech and pull the speech out. Vision, we heard about vision from Axelera. This is a very low frame rate, no network required, but it does face detection, can do feature extraction, can work out who the person is by identification, and then act accordingly. One interesting thing, I have a customer that's using this as the start point for an access control system, and because the part is like an FPGA in that you can reprogram it, you can switch it into voice processing, and then it can then actually listen to the voice of the person trying to get into the door. So not only have you got the vision, but you also got the voice detect as well, because the theory goes, I've never tested it, but if you get a cardboard cutout of somebody and walk up to a vision detector, it can get duped into believing it's the person. Knowing this is a hardware pioneers, I wanted to show you the architecture of the CPU, although I'd say that this is very different to anything you've probably seen before. The hardware ports around the edges are programmable in C, so if you want I2S, you want TDM, you want Ethernet, you want USB, you have connectivity that you can program. You download the code and turn the part into the part you want it to be. It has hardware threads, so these 2 cores, if you like, with 8 threads per core. So it can run threads independently, and the switch in the middle is used to communicate between the threads. So you've got a built-in hardware operating system running threads. It also means that those logical cores are event-driven, not interrupt handlers. So typically, if you've got an ARM core, for example, you get an interrupt, you dump a load of registers, you load a load of registers, you redirect the sequence of instructions to run either through an operating system or to switch context, which takes microseconds. The latency for a hardware thread on an X-core is around 20 nanoseconds. So your interrupt handler is starting straight away, depending on the signals you use, and you can attach those threads to the tasks that you've got in hand. So if you've got I2C or I2S or TDM or or Ethernet or CAN bus, etc. Whatever you're looking for, you can allocate threads to them to process it. It's made it very popular in the audio industry because they need the deterministic time and they need the response time and need a low latency. So it's very, very popular in audio, but it's also, because of the amount of processing power in there, those threads are going at 800 megahertz. We can do DSP. It's got a vector processor in there to do some of the machine learning crunching as an accelerator. And it can, as I showed in those examples, it does that without talking to the cloud. So I sort of summarised that the same part with different numbers of pins depending on the complexity of design. It's an event-driven compute, has onboard SRAM and onboard one-time programmable EEPROM, or ROM, so you can program the part and it'll run on its own. Has a vector arithmetic unit to do the machine learning. And a wealth of GPIOs. What I also want to show is this is the extent of the peripherals. So this is available now. So if you're looking for, as I said, crypto or DSP or machine learning or I2S or MP3 or UARTs, you define your peripherals. So if you look at an XMOS part, you can't find the peripherals you're looking for. They're downloadable from the XMOS website. And you can build them into your application. So it's I/O processing and control. It's got high-speed USB for audio, far-field voice and voice command, and AI audio and AI vision without the need for the support of a cloud connectivity. Thank you.
I missed it. Thank you very much, Dave. And then last but not least, we've got Ron Singh, who's just making his way up from the back there. Hello, sir. Come on up. It's from Digi International.
I'm lost, right? So
You are
I'm
indeed.
the difference between these good people and the pub outside. Wonderful. Sorry, guys. Okay, hello, everybody. Thank you this afternoon for making the time to come and listen to this presentation. It is me between you and the bar, right? So, okay, I won't drag this out. My name is Ron Singh. As I said, I'm the sales director for Digi for Europe and EMEA. Digi is a US company specializing in IoT hardware and software. We make SOMs and we make RF modules, but I'll go into that as the presentation goes along. As per the request of our colleagues here at Astute, this is very much a presentation about how our technology fits into the smart city space. So Digi's been around for about 40 years and has got a rich history of playing in the smart cities arena, whether it's smart street lighting, whether it's EV charging deployment or waste management. We can point globally to many customers and partners around the world for whom Digi has been part of enabling their technology in smart city applications. If I look specifically at Europe, we are here in many different applications. Up there in the corner, for example, are the smart bike or city bike schemes. That one up there is a photograph from the one in Paris. EV charging, I already mentioned. Solar panel farms around various parts of Europe. Street lighting, assisted care and elderly care, electronics and monitoring in, emergency lighting, transportation, all various parts of infrastructure that you would expect to see in smart city. And all of these applications and the customers that we've been supporting with this technology here rest very much on one or more of these oh, wow, okay, that was a bit urgent. One or more of these 4 pillars that we refer to within Digi's technology. And I'll expand upon each of these as we go along. We have a one footprint global certification technology. We offer a very, very fast time to market by highly integrated electronics and a fully supported board support package. We offer 10-year longevity of supply. Actually, in truth, we got products that we've been making for 15 and 20 years as long as the silicon is still available. And we offer very secure wireless technology, and I'll expand on that as I go along. So, just a couple of examples of where we're used. I mentioned solar tracking and EV charging. On the solar tracking side, there are very many ways. I don't know if you know how a solar farm works. You've got all the panels laid out with a pan tilt mechanism behind them, and there's usually one panel, which they refer to as a donkey panel. Don't ask me why. Its job is to track the sun and determine the most optimum way that the panels should be facing to get the best light to electricity conversion. That relies on pretty low latency because you're trying to move those panels. You might think it's tracking the sun. How quickly does it need to move? Another factor to think about is, and you think about the terrain where these panels are deployed, often bad weather conditions can kick in. You could have a sandstorm approaching. A sandstorm hitting one of these can do millions of dollars of damage. So there may be a requirement to fold up the panels or direct them in a certain orientation that protects them from that. So Zigbee is often used in this application. I'm very proud to say that Digi is very much market dominant in that sector. There are other technologies. You could use LoRaWAN, which we also offer, but you get more latency with that. WeSun is a new technology standard which is coming out. It came out last year and is very much pushed by the likes of Silicon Labs and other companies within the WeSun Alliance. We also have our own proprietary mesh technology. It's called DigiMesh. Unlike Zigbee, DigiMesh works both on 2.4 gig, but also sub-gigahertz, so you get much greater ranges. We can actually also support more nodes on DigiMesh, and unlike Zigbee, which uses 128-bit encryption, DigiMesh uses 256-bit encryption. I'll give you a nice little anecdote on that. We've got a customer in Europe who makes a certain piece of equipment. They've been shipping it around the world for years using our Zigbee technology. It's worked without fail. They were part of the Paris Olympics last year, and they deployed their product out as part of the installation of the Olympic Games, and they started having problems, dropouts. It wasn't working. It wasn't responding in the way it should have been. As you can imagine, the Parisian authorities were getting very nervous about this. This piece of equipment was being used in the Olympic Games after all, so they invited them in with RF sniffing equipment to try and determine what the problem was. Parisian drug gangs. They were using jammers to stop police radio, and it was having a knock-on effect on their equipment. So they reflashed all the modules from Zigbee to DigiMesh, which you could do over the air, and that 256-bit encryption made all the difference and solved their problem. Another market we talked about there is EV charging. EV charging is a very, very dynamic market. Right? It is an embedded design inherently. It relies on processor, wireless technology, various interfaces to maybe touch screens or POS terminals or so forth. But it's a very fast-moving market, and so customers can't take 2 years end-to-end to make an embedded design, get it approved, field tested, and out in the marketplace. The window of opportunity to capitalize on your design is much smaller. By using our secure embedded modules, customers are able to turn out designs in as little as 9 months and then go through the certification process. As I mentioned, Digi is a 40-year-old company, been doing embedded technology all that time. We have 2 product ranges. One is Digi Connect Core, that's our brand of SOMs. We take processors from the likes of ST Micro, or for NXP, we add the flash memory, the DRAM, secure elements, wireless technology, signal chain, power management, and produce a module that's about the size of a stamp. And like I said, we guarantee the performance of that for 3 years. So it's a 3-year warranty. We guarantee supply for 10 years. The next range of products we have is Digi XB. Digi XB, we celebrated last month shipping our 25 millionth module. It's instantly recognizable, at least the through-hole version, by those chamfered corners there. The beauty of the Digi XB module is that whether you are on cellular technology, sub-gigahertz, 2.4 gigahertz, supporting different protocols like Digimesh, Wi-Fi, Zigbee, the footprint and the pinout is always identical. So when you lay out your PCB, you lay out for one, you lay out for all. And I'll try and give you a good example of that here. Hopefully this will all work properly and I can demonstrate this. So this is our through-hole version here. This would be perfect for you to start breadboarding with, trying out different modules in your application by plugging into a socket. Once you were happy that was working, you would then move to our surface mount device. And there you would see that the pinout and the layout of the footprint remains the same. If you then decide you're ready to go to mass production, but you want to shrink the design, you can move from our SMT version down to our micromount version. So we always maintain the same footprint, the same pinout. Now, the example I used there was a module which is on 2.4 gigahertz. And that same module, as I mentioned, with our friends who had the drug problem, that sounds wrong, but the drug dealer problem, that's better, who were using the 2.4, so you could take that same module and then you could reprogram it. It's the same hardware, you're just changing the firmware, so Zigbee, Digimesh, 802.15.4, Bluetooth, what have you. But that footprint remains the same, so you could then move to sub-gigahertz in America, which is 902 and 928 megahertz. You can move to Europe standard, 868 megahertz, and then so forth for other regions around the world. And for every single one of those modules, which are all footprint, pinout compatible, we also offer different antenna options as well. And as I said before, everything is globally pre-certified. The beauty of this is if you are making a piece of equipment and deploying it around the world, you lay out one socket, you adopt all those technologies. Same footprint, same pinout. Often, if you move between the same, changing the footprint or changing the form factor, it's still the same stack. But XB is more than just those modules that cover all those technologies there. We also make gateways. We offer a wide range of APIs and interfaces to the likes of Amazon, Greengrass, or Azure. Telephony providers as well. We have certification. We also offer third-party support, either from ourselves or other partners on data plans and firmware bespoke designs. So we've got customers, for example, where we make a custom firmware because it's being used for the control of detonations. So absolutely cannot be interfered with anyway. We use a custom firmware on that. And everything that we do is wrapped around with a full suite of free of charge design tools which you can download from our website, including Mobile SDK, XCTU, which is our remote management, remote maintenance platform, and DigiFence, which is our trust fence security system. Why do customers choose Digi? Well, in the first instance, we make much technology accessible to many customers. If you look at MPUs, they are very, very complex to lay down. And to be honest, if you rock up to NXP or ST and say, I'm making 1,000 boxes, will you support me to go chip down with an IMX8? They're going to say, actually, no, we're not. So by using a module which is much more simple to mount and support, we make leading edge technologies from big vendors accessible to smaller customers. Actually, by using a module, you simplify your own carrier PCB. By using a module, you can strip out up to 4 layers from your carrier PCB, remove microvires, and just make your own carrier board simpler to upgrade over its life cycle. We wrap around a lot of value-added software. So we have a very highly integrated Linux distribution as well as an Android distribution. We integrate security software. TrustFence is our static software security system, but we also have a new one called Cloud Connect Core Security Services, which is much more dynamic and will look for active threats and send you updates. We have cloud connectivity as well, and that's really the differentiator between us and many of our competitors. We simplify supply chain, and if you think it was only a couple of years ago the world was in chip allocation, all right, there's up to between 250 and 415 components on some of our SOMs. If you were to go chip down and have to source all those components in the middle of a global pandemic or a global shortage of components, that's quite a headache when all you want to do is manufacture your product and get it out the door. By going with a SOM, you're ordering one part. You get it in, you continue manufacture. No, what we call golden screw, where you get 249 parts, but you can't manufacture because you can't get hold of that missing tantalum capacitor or memory device. And then finally, we offer up scalability or down scalability depending upon what you require. By using the same footprint and of our products, if you need to upscale from wired to wireless or from a smaller memory variant to a higher memory variant, you can do that simply because the pinout remains the same. Equally well, if you want to cost down your design and move from a higher end product to a lower end product, we allow you to be able to do that as well. You've been a great audience for not heckling me and throwing me out. I was waiting for the hook to come and drag me off, so thanks very much. I hope you've had a great day today, and thank you very much to Astute.
Lovely. Thank you, Ron. Thanks very much, mate. Well, thank you very much to all of our speakers there. I've got a little bit to finish us. Should be with us. Oh, dear. What have I done? Sorry. Stand by, caller. Might have been when I put the mic down here. Excellent. I'll pop that down and try not to bump anything. Lovely. Thank you very much. So, the franchise team that I mentioned earlier, you can actually see Kev Baker in the top corner there, in the back of the room over there. We're both here all week, along with some of the team. But you can see the technology areas we all support. In fact, there's also some blank pictures there. That shows quite how new those members of the team are. We're adding another one next month and another one in June. We're seeing more and more demand, more lines coming onto the company. And then our team of product managers in the background, they're headed up by Casey, Susie, Chloe and Daniel, who manage all of the interface for the suppliers, make sure your deliveries are going to be on time and make sure the projects are actually running as they should moving forward. I mentioned at the start the promise of test labs, counterfeit mitigation, counterfeit avoidance. I'll talk very briefly about what that actually means. ACAP, Astute Counterfeit Avoidance Program. It's a regulated test process. It was AS 6081. It's now AS 6171. We've been very heavily involved in actually the design of the 6171 test protocol. That's because in 6081 you've got all of this visual inspection right the way through to full destructive testing, and I'll talk about what that is in a moment. We've gone over and beyond these standards, and we've been market leaders here on the council for AS6081, designing this spec, advising other manufacturers or other test houses in the market how to go about this process. And this really comes down to when, as Ron mentioned there, where supply starts going tight. You can no longer get components from franchise distribution. What do? You buy from that Route C that I mentioned earlier, and there isn't a manufacturer out there or who hasn't been stung by buying counterfeit when they've been up against it. They're at line stop because they're out of components, and they buy from a chip house who's bought excess stock. Might be an empty package, might not be what they're advertising, might be genuine, but it's just been stored poorly, so it doesn't work. But we go through a full process of initial inspection, so that's making sure it matches the data on the data sheet. We look at all of the validity, the paperwork to show where it's come from, who it's been with for the last however many years, and then we start destroying the chip, quite frankly, to work out what's on it. So that can be scratching away the top of the surface to make sure it's not been blacktop, remarked, it's not been reballed. We go through to X-rays and spectrometry. So you're then inspecting to see if there is actually anything inside of the package. And then we run through solderability testing. So we actually use the very worst solder you can get, the very cheapest product, because if that works, when you use it in the ideal environment with good quality solder, you're away. Right the way through to that destruction there that I mentioned, so decapping or delidding, and that can be dissolving or melting away the package and inspecting the wafer itself and saying, yes, this is a genuine part that TI, that Xilinx, that Samsung, that Micron built. Genuine part, here's an Astute 10-year warranty on top. So for those customers that really do need to be a genuine solution, what we're effectively doing is building up an evidence case. We're to say either, yes, this is genuine, or it's suspect counterfeit. We always get asked how much suspect counterfeit we see. Frankly, not that much. But that's because of the relationships we've built up and the supply chain sources we've built up over the last 35 years. We know who we can buy from, we know who we can't buy from. We're part of the council that, so if we find anything that's suspect counterfeit, it has to be stored for another 3 years, destroyed with a hammer and a chisel, then report to the manufacturers or the distributors. So when Astute come asking for the stock and they might have a suspicion, they won't sell it to us. We don't offer this as a third-party solution, or in very rare cases, primarily because if one of our competitors has bought the product, sold it to a customer, and a customer asks us to test it, if we say we think it's counterfeit or have reason to believe it's suspect counterfeit, the other distributor is going to say, well, of course they say that. So it's not really somewhere where we think we can add value. We'll do it in extreme cases, but it's for when we're buying from Route C, non-traceable. The integrated services, I've actually covered that fairly well earlier, but the part that leads into, I mean, things like direct line feeds there, so we can actually have, so I mentioned about kitting, about packing, about shipping from our facilities around the world. We can then actually have Astute staff embedded in the site of the customer, taking that delivery in, making sure it's stored in accordance with the customer's wishes. And say things like direct line feed is absolutely very much a part of what we offer as a service. But AIS, Astute Integrated Solutions, and actually the whole of Astute is really about understanding what our customers need. We'll tell you, and it's the one thing I'll ask you to take away from today, is don't look at what we have as a shopping list of these are the services Astute can offer. Come to us and tell us what you need. Tell us what problems you've got. Tell us what headaches you're trying to solve. You've been everywhere else and can't manage. That's how our business has been built over 35 years, of solving problems for customers. So all of these services have come about because someone's asked us to do it. And we're adding capability all the time. This is a prime example. So we had a customer in a program that I probably can't name, but extremely long term. So an FPGA that went obsolete. They cannot retest, quite frankly. 5 to 10 year retesting cycle, tens of millions of dollars to reapprove that. So what do? They ask us to store it long term. So we've got components in nitrogen storage chambers where they will not degrade over time on a 30-year PO. So because a customer asked us to do it, we offered a service. We'd like to say you won't find that elsewhere. We don't know of anyone else who does it elsewhere. But again, if you have something different, come and ask us. Tell us what you need. we've won quite well ahead of schedule there. So you'll all be pleased to know that's the end of the presentation. Thank you very much to my speakers. Thank you for being prompt and actually quite brisk through the presentations as well. Are there any questions for anybody? Lovely. Okay, well, if you do think of anything, we're downstairs. I believe it's C1. We're at this end of the hall. Come and find us. We'll be at the drinks reception tonight as well. Thanks very much.